and then we discuss about more extensive NMR. Yeah? And then you become NMR expert in the world. Very few of you. Okay.
Sir, I think we can select 10 top scorers and then bring them to Islamabad and then have this full tags, one-to-one discussion.
Yeah, we can select all of them. If they're willing to go by road.
Yes.
All right.
Yes. Whatever you do.
From Karachi to Islamabad is 1,600 kilometers. You have been there. Is a torture. And it takes about 20 hours. And it's a beautiful drive. You stop at different places, you take your breakfast, lunch, dinner, whatever. And it's a beautiful country of our world. And it is still in Islamabad, which is about 700 kilometers from the northmost border of Pakistan, which is close to China and Tajikistan. Okay. So let's plan that at some point of time. We will have a big bus, okay, and you all sit there and start, and then Hani will sing songs and will entertain you for the rest of the journey. You know songs, right? You're a singer. You know a very famous one, but it's still the
You will stop talking massage.
Okay, everyone. Bismillah. And good morning, not good afternoon. And that this is exactly what I was telling you, that there is some correlation between proton NMR and C39. Some correlation, not very linear one. And correlation is very simple with the fact that shielding is shielding for proton and carbon, and de-shielding is de-shielding for carbon. So you can get some approximation of if a metal is coming at 1.5, where most likely the carbon would be. It's carbon. So you get some approximation, and there is this is my first sentence. I mean, even the judges never stop if you're giving me a statement. And anyway, I love this questions. I love everybody's questions, and I never guarantee the answer. Okay, so anyway, so for instance, these are aliphatic. Alcohols, ketones, amines are here because you know that there is an hydroxy group and there is an oxygen, nitrogen, etc. So somewhere between here and then olefins are here, and then aromatic and amides and acid and aldehyde are somewhere here. With some level of correlation, aliphatic would also be shielded. Olefins are, this is almost some linearity you can see, right? And I would say if it is 2, then 40, something like this, some correlation. It's not linear, you know. And so never think that you would be able to get exactly the same level of correlation if you, but this is what you would be able to see. You know, but think of it. There are protons which are here in minus. TMS is an assumed trimethylsilane, tetramethylsilane, is an assumed 0 because they are very, very shielded. At some point of time when people have selected TMS, was the most shielded compound they could find it, right? It was a time when proton NMR was appearing as a new technique, and they could get hold of a small molecule which was so cheap, soluble, and was shielded. So they assumed it to be at zero. But you see, now later, when people start working on proteins and all that, they found that there are proteins and their vessels, their protons, which are actually in minus. They are super shielded. They are more shielded than TMS. Okay, so it's possible that you have chemical shift in minus. It depends on the shielding, right? So this, I want to make it clear that it's not an absolute rule that everything is left of TMS. It can be right of TMS, and it could be shielded also. Okay, so having said that, this is the kind of scale you expect for carbon and proton. And we have already discussed that there are 5 factors which affect chemical shift. The most important is their electronic environment. This is affected from the inductive effect, hybridization. Okay, hydrogen burning. Somebody corrected me. Yes, hydrogen burning. What else? Magnetic anisotropy and temperature. Okay, and solvent. Because if you have a solvent can affect. Because solvent is a real molecule. Is a real molecule with polarity, hydroxyl groups, whatever, so it can affect them as well. Okay, so now I want to show you any idea of coupling. When you see an NMR spectrum, proton NMR spectrum, one-dimensional NMR spectrum, is actually a two-dimensional NMR, isn't it? Because X and Y-axis integration. It's not frequency, it's integration. So it's two-dimensional, but in NMR spectroscopy, integration is not considered as a dimension. Okay. So integration and chemical shift on x-axis. Okay. And then you get number 1, information about chemical shift. Number 2, you get information about the number of protons under the same magnetic and chemical shift. And 3, you get information about their neighbors, coupling, which is very, very important, because that make NMR exciting. Chemical shift, you would know, okay, how many different types of protons you have, what is their electronic environment, but how would you assemble the structure? You can only assemble the structure if you know who is next to what. So that is the coupling, right? And that coupling appeared as splitting. And that splitting, the easiest way is n+1. You know this, right? If there are 2 neighbors, you will have triplet. If there are 3 neighbors, you will have quadruplet. If you have 1 neighbor, doublet, right? But what actually happened is today's topic. That is what we're going to learn. And if you understand that way, you would be the only one on the face of the earth. You would be very few among the people who understand coupling to the core. Okay? This coupling to the core. So then I need to have NMR spectrum. Here, do we have NMR spectrum somewhere?
can finish food.
Yeah, simple proton NMR of, let's say, ethyl chloride. Okay, so let me write for you.
Like this.
Ethyl chloride. Okay. This is ethyl chloride.
Yeah.
Okay. Oh, what? Okay. This metal will appear as triplet. This CH2 will appear as why? N plus 1 is not a magic number. There must be some reason, brother.
Because number probabilities protons will
Okay.
be in the same
So,
direction.
triplet.
Next topic.
Very good try. CH2. Sorry. CH3, right? Happy with it? This is the most wonderful drawing. It's very close to what Mona Lisa was from. Okay.
Very EMI structure.
It's too complicated, madam. This is a simple one which I have drawn. Okay. Now, why do you think that this metal appeared as triplet?
Just two hydrogen present in your ring.
No, and then these three peaks are not equivalent.
Then Pascal triangle explain the intensity of the.
I don't want to talk about Pascal. I went to Pascal. I was walking in Strasbourg, France, and I saw someone with a stick passing on the street also. And one of my colleagues said, "You know him?" I said, "Who?" He said, "He's Pascal." So I went to him, I shook hands, I said, "Can you like to have coffee with me?" So I know Pascal then. But I really want you to understand the core of it. Okay. So let's talk about this method. This method. Okay. And these two protons, which are splitting their metal into triplet. And I want to shock you. I want to shock you that this is not a triplet of a metal. This is three different signal of a metal. Three different signals of metal. Shocked? Not shocked? Somewhat. Okay. Very metal. This metal, right? Another. And these are two CH2s. One CH2. Come. This metal is washing them in three different states. three different states. One time this metal, why don't you just have your hands up? Both hands up. Okay. But this two hands up means that the direction of their magnetic field is aligned to the magnetic field. And that add the magnetic field which he is feeling. So magnetic field be effective would have contribution of these two magnetic field which are aligned to that. Okay? This is more shielding, right? So this peaks appear. Okay, this peak appear. Okay? Yeah. Honey, straight. Up. And okay, this peak appear. Surely, because the both of them are in the direction of aligned to the magnetic field, and as a result of it, the B effective is adding, right? One more. You're confusing me. Okay. Now this is one peak. So this method is a genuine method. You know, is this method, this signal is a genuine signal. It has nothing to do with any coupling. Understand? Now, one of them is down, I opposed to the magnetic field. One is magnetic field. And then vice versa. How many probabilities? Two probabilities. One down, but two different. Two probabilities, right? In one case, Adil is up, Hani is down. Other case, Hani is up and up is down. This is another signal. Okay? This method now see them one up and the other down, and the vice versa. So is a twice the method is now watching the neighbor in two states. So probability of them is double, right? So this signal is a method, a genuine method. Genuine method. It's not, and has nothing to do with splitting. Genuine method which is appearing twice of integration than this. Okay, and then go down, opposing to the magnetic field, right? A bit deshielded, opposing. This is a genuine signal also. Okay, so this method he is actually, it exists in three conditions. One in which he has neighbor up, other in which you have one up, one down, twice, right? And the other in which both are down. And it's just adding the magnetization or subtracting the magnetization. So method is actually in three different states. One in which magnetization is strengthened, one in which magnetization weakened, and the one in which magnetization is almost happening. Right? So these are three signals of the same method. No coupling. But since they appear as triplet, we call it coupling. We call it splitting of the signal. Collectively together, this is one method. Okay. Now I need for this I need 3. One more. Okay. So CH2. Now you're watching CH2. You're CH2. Okay. This is natural. The 3 protons. Give me probabilities.
Maybe over us all.
One. Okay.
Over us down.
Down.
So you will break one up.
And one down.
Go down.
Now middle down and
How many probabilities? Just count the other 2.
2 up and 1 down, and where it breaks 2 down and 1 up.
But then,
But which one?
why
Which
is
one?
the pairing is and twice in this? Explain this.
I can explain for you.
No, you explain it by gymnastics.
Yes.
Okay. 2 up.
2 up, 2.
Honey, we should be right? Okay. आप आगे को lose करें. Okay. 2 down.
ये डाउन हो गई
Honey up. How many probabilities?
ये डाउन हो जाएगा
This now
ये up हो जाएगा
Wow, good. Right? And then another one.
and then if I is down
Okay.
and then one up two down then one up two down and then is up and
One from girl should come and give them direction. You don't need to hit them. Okay. One of you, volunteer. Come. Anyone? Anila. Okay. Thank you. I want this. It's so easy for me. Shielded because all 3 are up, or a bit shielded or 3 down. But I want to understand these 2.
All of them up. First one, second one, all of them down.
This one,
Okay.
right? Okay.
And one will be up, two will be down. Then you down and all, both of them are up. Now one will be up and all two
How
down.
many probabilities of this one? This shielded, right? This is shielded. And this is slightly deshielded. So, right.
Yeah, and one will be down and both two ups.
Oh.
Yeah, you. Now both two downs and this middle will be up.
How many probabilities? Why don't you draw that on your
Genetic one is 3 lines.
yeah,
1 3 3
yeah. So, understood? Understood? This is never in any book anyone will tell you that these are not actually abstract or magic. They are real method. Method exists in 3 forms, and CH2 exists in 4 forms because neighbors are different. Okay, so everyone will teach you about coupling, everyone will teach you about splitting, but nobody will give you the explanation that they are actually genuine signals. Genuine signals. Okay. Thank you very much. Now, after so many of these classes, you would start considering yourself as protons. Right? Yes.
in case of no propane
Make a chloropropane. Take this also. Okay, honey, I stopped you for asking a question. You can ask me that question now. Please. Sir.
You have a question?
I want to help you.
even the feels like that about the relation between the NMR carbon NMR and proton NMR. Here, we take a review before about the magnetic field. The proton is more 4, 5 carbon 15. One we didn't apply this there. For example, if we have
No, question, repeat the question.
we take with you about every time the proton, the magnetic effect about the proton in NMR is 4, 5 carbon 15. Why we didn't apply here? Let's say.
Because we're not discussing the sensitivity of signal. We're just discussing the chemistry.
But all of them in the magnetic environment.
Yeah, but you see here, you are detecting one and the other separately. You understand? The NMR is the only technique in which you can select the radio. Remember radio? So you can have radio on proton and you can have radio on C13. C13 is very insensitive by multiple factors. Number one is only 1% of natural abundance, right? While proton is close to 100%. Number two, paramagnetic ratio of C13 is 4 times less. So it's a weak magnet. It's a weak magnet. So, and there are other factors also. So C13 would always be very, very weak, right? But here we're talking about correlation, some correlation between the chemical shifts. Okay? That is the reason. Thank you. Now, Shusa, come. You want to ask question? But they're just too small. Draw it again, a bigger one.
Confused.
Which one? Be confused, correct. Okay. Someone should try to solve this. You make a circle on it. What do you think it will appear as? No. Not multiply. But 3 plus 2 is 5. So 6 times? Okay. I need 6 people. How many times would you like to come? Come. 6 people. And now this time I'll volunteer myself to be this CH2 which is circle. Okay, I am CH2. I'm CH2. Okay. I wash them. Now you split yourself into 3 into 2. 3 into 2. Okay.
Again,
No, I sit in the center. Okay. This is my metal. This is my CH2. Okay. All up. One state, you make this 6. All up, 6. Okay. All down, easiest. Okay. 5 up. 5 up.
We are 5.
One is more.
Oh, wait, there's one more. Yeah. This 3 and this 2.
You have
Charlie.
Okay.
All are gone.
Sorry, 5, not 6. Okay. All up. So I wash them. Okay. They are adding into my field. Okay. So my B effective is added by them. Okay, because they are in the same direction and they are magnet. I am a magnet also. I have applied magnetic field. In applied magnetic field, they are adding a little magnetic power into me. So I feel it more. Okay. All down. It's bad. They should be, because they are opposing my magnetic field. Okay. 4 up, 1 up. How many combinations? 4 up. Okay. 4 up. 4 up. 4 up. How many combinations? 1. Okay. And now 4 down and 1.
2 down, 2 up.
3 up. 2 down. 3 up.
1 of them.
Down. You understand?
Yeah.
Okay. Honey, what is your problem? I have to sit with you in a separate room and answer. You don't see me happy. Okay. Okay. 2 up, 3 down. Okay. And combination. Right? 1 up. 4 down. So many combinations. So you see this me as a CH2 is separate, you know. Me as a signal, C all up, and I have my signal. Me as a signal, all C down, and I also see various combination of my neighbors up and down. As a result, this I would appear not as a one signal but 6 signals, because I see my neighbors in a different conditions, and these 6 signals would not be same in integration. They would be different because the combination are different. Okay, understood? If you understood, I am a happy man. If not, I will try again. You still confused?
Because 12 signals
12 signal?
yes.
12 signals would never appear in any of this kind of a molecule unless it has an asymmetric set. There is a different thing which we will study later. I don't want to confuse you right now. Okay? He's talking about departure of n+1 rule, which comes later. You know, that is a different domain altogether. We don't want to get into it. Okay. Now, any question about this? You now understand coupling? But coupling in a real sense, it's not a magic number n+1. It's not a magic number, it's a real signal. Triplet is 3 different signals. Quartet, there are 3 different signals because the probability of watching these neighbors are in different conditions. And the distance between them is coupling constant. It's going to be same because metal and CH2. Okay, so this is what we wanted. Okay, so all what we have studied was one-dimensional NMR. And one-dimensional NMR has a pulse sequence like this. T1 time, 5 T1. Okay, before the other experiment, 90 X pulse, and FID. This is the simplest experiment which you can do for proton NMR or C13 NMR. Simplest experiment. Nothing simpler than that. And before you start other experiment, this one, scanning, you need to wait for 5 T1 time. It's called relaxation, delay, or whatever, so it's just you have to wait. You want to make sure that before you apply 90 X pulse, magnetization vector, net magnetization vector, and not is at the right place. You don't want any distortion because If it is not in the right place, errors keep accumulating and you will have no. These are put on NMR which you get, and this is alpha 5, very small aromatic compound which you isolate from plant. It appears this is C13 NMR. C13 NMR of this 5, 6, 7, 8, 9 sequence. Okay. 6, 7, 8, 9, 10 sequence. Okay, so it's a monotopy. It's a monotopy. Okay, someone should come and interpret that C13 for me. I'll volunteer my most competent student, Professor Dr. K. Based on the chemical shades.
So you want to tell why they are doublet? And why?
Doublet, triplet is very simple. N+1 rule. A methyl will appear as a triplet, as a quartet. And CH2 will appear as a doublet because carbon proton, all carbon which have proton are coupled with them, right? And will also be splitted. So this is a fully coupled C13 NMR. Fully coupled C13 NMR. When people start recording C13 NMR spectrum, this is what they have got. Even for a small molecule. Can you distinguish that? It's not easy for me, to be honest. I don't know, what is this? Think of it, even for a small molecule like this, I still would have a difficulty. Like, what are these signals? Because coupling is making it extremely complicated, even for this small molecule. And think of steroids. Absolutely. And then think of a protein with 2000 proton. Carbon 13 of a protein. So it's going to be a nightmare. Let Dr. Adia interpret that.
Okay, so since it has coupled, fully coupled, and
No, not
decoupled spectrum.
No, don't talk about this. This is my
Then
prescription.
how would I? There is no chemical shift written, so that's why I need.
You just tell which is what.
Okay, all right. So this is down the most
No.
down. Then what? This one.
Yeah,
I need to explain this.
yes,
Okay.
because I cannot.
You are suffering because of the same situation is defined began.
Yeah.
I'll bring enhancement.
Okay. I'm going. The most down. I'm not here. This is the most downfield signal, and since it is fortunately we have a structure here. So looking at the structure, we can see that it's not coupled. So it means this is quaternary carbon. It doesn't have any proton attached to it. That's why it is
So
single.
simple. Life is so simple.
Yeah.
Which one is this?
And this could be this one. Since this one is the quaternary and it's a double bond. So this will shift most
Assume if you don't have a structure, you interpret that. It's so easy because she can see doublet and triplets.
Yeah.
The problem is she can't interpret. A lot of things cannot be interpreted.
Here it's really
No.
okay. Then we come to the next downfield signal, which is a doublet. Right? Since it is a doublet and it's a downfield, doublet means this carbon has one proton attached to it. Since carbon is we are observing C13 and all protons 99.98% proton are NMR active nuclei. That's why proton is split because of the carbon is split because of the proton.
The same
because all-
philosophy. Carbon is watching two neighbors.
Yeah.
Or one neighbor or whatever.
Since-
In this case, one neighbor.
if since it is a C13, that's why all C13
has NMR active nuclei purity 99.98%. So this is doublet, which means it is CH, right? And it's a downfield signal. So we could assign this here, right? And then this is a solvent signal.
Don't go to down.
Okay.
Okay. Up.
Where this is solvent.
Okay, yes, fine.
So we need to compare.
Yeah.
Again, huh?
Yeah, that's a good question. Okay. All solvents are known. You know, everybody will give you a table that if you get GMSO or CH3 or C or chloroform or dichloromethane, anything like that, acetone, the signal will come at this place. Okay, so it is table. Of course, this is also interpretable. You know, there's a compound, and you also know where they would be because you know about shielding and de-shielding. Next,
Okay.
what is
so-
this doublet?
Yeah, this is again CH here. So CH could be here or CH could be here. Either of
Which one is this?
these. This could be this.
Yeah.
one.
Exactly, that's
Yeah.
close to double bond.
Yeah, that's that. And then again CH. That will be here. And then,
So neat, beautiful, right?
yeah, and
Life
this,
is so easy now.
yeah, and this one is singlet, which is quartile here. Okay. So now we are getting in tower again. And this is triplet. That is CH2. And now we have, where are the CH2? We have two CH2 here, CH2 here. And definitely, I think this would be the one. Because of,
I don't know.
yeah,
Anyway.
right. And then, now it's complicated.
Now it's going to be in three methods.
Yeah.
Three
And
methods.
the problem here that I could see, you know, the macro means it should appear as a quadrant. So there is one quadrant signal here, but this quadrant signal is also like very close. I don't know which one is there. And
Which signal belong to which quadrant?
yeah, and here again the quadrants are overlapped. So I don't know where which quadrant. There are one three maples. So one like maybe this one or this one.
Even such a small
This one is
molecule,
so it's
you get into trouble. Thank you, madam. Yes. Let's do this from your interpretation skills. She interprets proteins, so we expect her to interpret this also. Her performance was 70% correct, actually, 100% correct. So, you know, so you have so much information. Now I'm going to take you to the real NMR. All information is there. You know, these triplet quarters give you so much information because you would know which one is CH2, which one is CH3, which one is CH, right? Problem is that even with such a small molecule, you can't interpret that, isn't it? And think of steroid, think of a big molecule. This is going to be a nightmare. So scientists like Ani were sitting in the labs and they said, good God, I mean, it has so much information, but it's so difficult to interpret. So why don't we just decouple, you know, and just get rid of protons and get one signal for each carbon. No triplet, doublet, anything like this. So they got something like this. How they have done it? Anyone wants to go to Samala?
Thank you. No, switching.
Like pulse.
Decoupling, yeah? How would you decouple?
Switch on the proton and never switch on.
Okay, so you're close to ringer.
180 पर स्टेटर से डीकपल कर देंगे या फिर उसकी स्पीड को बहुत ज्यादा कर देंगे जिससे वो टाइम ड्यूरेशन बढ़ा देंगे
to frequency.
Let her.
Time duration can be increased because in general experiments we just provide a pulse. So I'm not sure, but I think it like that we can increase the time duration. So And continuous RF, it can be different.
Okay, this is one explanation. Yes, sir.
To decouple, you said before to decouple any bond there, you can use two parts to express.
Yeah. Okay, so you all are right. You all are close to circle. Some are 10 kilometers short of circle, some are 10 kilometers ahead of circle. You're close to quarter loop. Sorry. Okay, so it's called decoupled, fully decoupled C13 NMR spectrum. And what you have done, a very simple trick. Now we are playing with both of them. You have C13, you flip them in XY plane, and then you also have another radio frequency oscillator. Turn on that radio frequency oscillator on proton frequency. Proton will move like a fan, and the carbon would see nothing but time averaged neighbors. Time averaged neighbors. Like, if you have a fan, you can see the roof. Right? You have no problem. If fan is running very fast, you can see the roof. You see nothing but roof. Okay? So when you turn on the radio frequency oscillator on proton frequency, proton will start moving like crazy, and the carbon will not be able to see it. As a result, you get fully decoupled C13 NMR spectrum in which each of them, each peak represents one carbon. Now there are two observations. One is that all are carbons, right? But they have a different height. Yeah? This is the reason in C13 integration is not reliable. There are reasons which we will discuss later. Second, if I have this in front of me, I know carrier ships, but I lose a very important piece of information. I get into trouble. I don't know which one is CH3, which one is CH2. Okay? So I solve one problem, and then I created a new problem. Okay? And that is from where an absolutely new chapter in NMR spectroscopy started, which is called attached proton test. How do we know which of this signal is CH3, which one is CH2, which one is CH, and which one is cortical? Okay, so this is the development of C13. You see, it's so exciting. NMR is so exciting. Someone tried to solve a problem, create a new problem. Then they create a new solved problem. Wonderful, you're so wonderful, but I think your absorption and my absorption capacity is over now. And we will, inshallah, discuss now 5 minutes. I would invite questions. You can ask see any question. We have moved a little bit, not much, but important. We learn coupling, the real sense, the real definition of coupling, which you will not really find in any NMR program. Because nobody will tell you that this triplet is actually three signals of three separate signals. But simple version, NMR, everybody is trying to make NMR simple one. And which is fine, but you see, fun is learning. Learning more is fun. Any question? And then, of course, we gone into C13 just to let you know that coupling can also be a problem. And when you solve coupling problem, you will run off another problem. Yes.
So it is not today's topic, but I have a question. Can we attach NMR machine to another technique like HPLC or something? And if we have to see our running compound, because there is no fuel cap.
Okay, so question is very important. Said if can we couple chromatography with spectroscopy? It's called hyphenated technique, right? Can we have an LC-NMR in which we can have separation and analysis together? This machine is available. We bought that also. You know, we have LC-NMR machine in our institute. But it's not perfect. It is the most difficult hyphenated technique. You know why? Because assumption was a very simple one that instead of you know having one NMR recorded and then second NMR recorded and all that, why don't we just have one compound coming after the other from LC column? But there's a problem. It's an interfacing problem. Interfacing problem. Number one, that proton all the NMR experiment has to be in deuterated solvent. You will never be able to run HPLC in deuterated solvent. It will make you bankrupt. You will be in the street. Okay. So number one. And number two, that the volume of solvent which you need for solvent NMR is to be little. You don't want a lot of volume. Number three, all HPLCs are run with lots of solvents, non-deuterated solvents. Okay, how would you interface? How would you remove solvents, add deuterated solvent, and move them? And for that, a lot of development, many, maybe 1,000 people have done their PhDs on this interfacing. People have developed techniques such as SPF. क्या कहते हैं SPF? Solid phase extraction, solid phase fractionation. So many interfacing were developed in which the solvents come. There is an automatic drying, automatic adding of deuterated solvent. But it's a nightmare. NMR at the same time has a problem. NMR wants time. It's a slow technique. HPLC needs no time, one after the other. So they created a loop. They created 5-10 meter loop. So there is a time delay, right? Lot of problem. And as a result, there are labs where people are using LC-NMR, but to be honest, just a show. Actually, they isolate compound, they go and they just tell them that. Yes. You understand, in so much of development issues which LCMS is okay. No issue because MS is fast. It doesn't care about the nature of solvent. It can burn solvent of any quantities. You know, the temperature is just so absolutely high. LCMS is no issue. Interfacing is no issue. Okay. Yes.
And my question is that as we discussed this complex molecule, they are having
It's not a complex molecule.
the signals are overlapping in nature. So most of the compounds we have like nanozymes or proteins or complex macromolecules also having facing the same problem in NMR.
Tremendous.
Some signals are suppressed and some are so enhanced. So we are difficult to predict which is method and which group are present or not. So how we discuss deal with that kind of chromatogram?
Number one, you do this decoupling, but then you have a problem. You don't know which one is CH3, which one is CH2, which is so important for you to interpretation. So now I'm leaving you with a problem, not a solution. We will discuss the problem, the solution on Saturday. Yes, sir. Okay, so complex molecules, this problem is even more because emission that you have, let's say cholesterol or a tritopene with 6 metals or something like this. how would it appear, or CH2s, 9 CH2s? You would never be able to recognize them, except carbonyl group or olefin. Yes.
You said about the space. When I visited the lab to see the NMR machine itself, I see like cylinder, and we look for something like this situation. Where is the magnetic field? Is free in it. So I am thinking, where is the poles of this magnetic field? You have north and south. So they will be here, not here. How will you are going for all this slide about the Z, or the
Yeah, no, it's all right. No, it's all right. It's okay to ask questions. You see, sample is put from above, and there is a board which is called probe. You have seen it, right? And then this magnet is a vertical magnet. No, is a vertical magnet. Yeah, so it is a vertical. Horizontal is in MRI. In MRI, it's a horizontal magnet when you place a person inside. Okay, so this is a vertical magnet. Vertical magnet. And when you have vertical magnet, up or down, isn't? Right? So this is a vertical magnet, like this. There is a whole cylinder of wire which create a magnet. So it's a vertical magnet like this. And naturally, you can't put a person from above to down, right? So they develop a horizontal magnet for MRI. So vertical magnet, when there is a vertical magnet, the poles would be up or down. Okay? Thank you for a good question. Any other question from anyone? Any question from the? Okay. Let's see you inshallah on Saturday. Assalamu alaikum.